In Bayesian reinforcement learning, you're stuck. You need a likelihood function to update your beliefs, but in real-world environments or complex simulators, that likelihood is either intractable or completely unknown. Enter LF-IBIS, likelihood-free iterated batch importance sampling. It's a fully Bayesian framework that merges approximate Bayesian computation with iterated batch importance sampling, structured inside a sequential Monte Carlo pipeline. The goal? Online posterior inference over both environment dynamics and optimal policies, without ever evaluating a likelihood. Here is how it actually works. Instead of computing exact likelihoods, LF-IBIS simulates pseudo-trajectories from your generative model and compares them to observed interactions using a distance metric and a hybrid ABC kernel. At each new time step, it doesn't restart inference from scratch. It takes the existing particle approximation of the posterior and reweights those particles using a likelihood-free ratio of simulated trajectory probabilities. This sequential reweighting is the IBIS core. To prevent particle degeneracy as data accumulates, the algorithm adaptively shrinks the ABC tolerance threshold using either the effective sample size or the count of unique surviving particles. Crucially, it doesn't just infer environment parameters. It propagates the full posterior over those parameters directly into the optimal policy itself. By sampling policies from this posterior, the agent gets a natural, uncertainty-aware exploration-exploitation trade-off. High posterior variance drives exploration. As the distribution concentrates, exploitation emerges automatically. The researchers validated this on response-adaptive randomization for clinical trials. Because that setup admits a conjugate Bayesian solution, they benchmarked against exact inference. LF-IBIS matched the exact posterior closely, handled both observation-based and utility-based summary statistics, and remained stable even when the posterior lacked a closed form. This isn't just another likelihood-free workaround. It's a principled online full Bayesian RL method that quantifies policy uncertainty and adapts decisions in real time. If you're working with black box simulators or data-scarce sequential decision problems, LF-IBIS is exactly the research you need to read.